your book every day till the end of the year. No.
Is there a lot of pictures of them?
Chapter 27, thermodynamics. If you break the word down, thermal is heat, dynamics is change. We're studying the change of heat. It goes from one place to another, and using it to do something useful. For example, you take a gas, put it in a chamber, you explode it. It makes heat. But then what? Well, that chamber expands, pushing a piston. That piston then pushes a crankshaft. That crankshaft then spins the drive shaft. The drive shaft spins the wheels, and the next thing you know, Miss Thompson, you're driving yourself over to DQ. Taking a heat exchange, an exploding gas, turning it into work to drive the wheels on the car.
So the faster the car, the thermodynamics are involved.
Yes. The faster the exchange. When you go to college, you'll take a whole year course on thermodynamics. We are going to spend a week. You're getting dipping your big toe in the pool of thermodynamics. But I do think it's one of the neater subjects in chemistry because when you're studying heat exchange, you're typically studying explosions. Now there's some terminology we need to get straight before we can talk about thermodynamics. And two of the first terms are system and surroundings. The system is the area under consideration by the scientist. And the surroundings is everything else. So the system is the area under consideration by the scientist, and the surroundings is everything else. So, what the heck does that mean? So, you get to decide, Meredith, what is the system. As the scientist, you decide what the system is. So, Meredith wants to study pollution on Lake Mendota. And she is going to define as her system Dane County. So she is going to look at all the pollution produced in Dane County and how it affects Lake Mendota. Okay? That's Meredith's choice to look only at Dane County. Dane County would be the system. Everything else, literally the rest of the planet, is the surroundings. Now Cade could do the same study. He wants to study pollution on Lake Mendota. But he could define his system to be the whole United States. Okay? So he's taking into account LA and Denver and Austin and Phoenix and Milwaukee and all those other cities. Okay? Meredith is just focusing on Dane County. Cade's focusing on the whole United States. Is one better than the other? No, they're just different areas of study. We can learn a lot from Meredith, we can learn a lot from Cade. But as the scientist, you determine what the system is. What are you going to focus on? Now there are two types of systems. You've got your closed system, where there's no exchange between system and surroundings. And you got your open system, where there is exchange between system and surroundings. So I want to study the wolf population on Isle Royal. Has anybody ever been there? Yeah? Oh, Tom, yeah? Beautiful place.
What is it?
Isle Royal is an island in the middle of Lake Superior. It's right there. It's a big island, but it's also away from land. So you can't swim there, Sierra. Sorry. So if I'm going to study the wolf population on there, that's my system, Isle Royal, 40 miles long by 8 miles wide. Can wolves get there from Wisconsin? No, because it's an island. It is a closed system, okay? Wolves can't leave the island, wolves can't get on the island. Okay, there is no exchange between the system and the surroundings. But what if I wanted to study the wolves of northern Wisconsin? Okay, northern Wisconsin is now my system. Everything else, Minnesota, Iowa, Michigan, Canada, that's the surroundings. Can wolves leave Wisconsin and go to Minnesota?
Yep.
Yep. Can wolves from Minnesota enter Wisconsin?
I do it all the
Right.
time.
So, that is a open system, okay? Because you can exchange between the system and the surroundings. So, any questions on those definitions before we move on? Then two more definitions before we start doing the math. Our state functions. State functions are path independent. Shoot, scratch that.
Oh.
Whose value is path independent.
So we have a value of independence.
So whose value is path independent. And a non-state function is value is path dependent. Yep, Brianna.
What do you mean path dependent?
Good question. So, you know where Milwaukee is, Brianna? Okay. How many, what's the distance to Milwaukee?
I don't know.
Give me a guess.
75 miles.
Okay, 75 miles to Milwaukee. Okay? I disagree with you, Zach. I think the distance is 2,000 miles. Why, I hear laughter. Why is that?
It's a little
I'm right.
That's right.
Take the long way.
That's like you get lost, Florida, and
So, when Zach says 75 miles, his path is going from Madison along I-94 directly east to Milwaukee. Okay? If you go that path, it is 75 miles. The path I'm taking is I-39 down to New Orleans, grab a beignet, and then I'm going up to Chicago, and then over to Milwaukee. That's 2,000 miles. Okay?
What's a beignet?
It's a donut.
what kind of
They're
donut is
so
that?
good.
A beignet.
Beignets are so good.
Baguette,
What makes them special?
they're French.
You just
Maybe
can't.
does it look like a donut spoon?
No,
No.
you just can't
It's like a little
describe
puff
it.
pastry.
It's so
It's
good.
like a croissant, but not quite.
Like so it's not a
It's
spoon.
got powder on it.
There's no sugar on it.
A
Yeah,
beignet.
no, it's so good.
I'm sorry I brought that up.
I like my American donuts.
So, anyhow, to answer your question, Brianna, so distance is a path-dependent value. So both Zach and I are right. We just took different paths to get there. So distance is a non-state function. So what would be an example of a value that doesn't depend on the path, something that is path independent. So Madison is 340 feet above sea level. I'm going to take I-80 to Denver. Denver is 5,280 feet above sea level. So if I drive along this path, Tom, and I drive to Denver, I'm starting at 340, I stop at Denver, what's the altitude of Denver? Foster?
5,280.
Yep, that's the altitude of Denver. Okay, now I'm going to take a different path. I'm going to take 39 all the way down to New Orleans. New Orleans has a altitude of -4 feet. It's actually below the sea. Then I'm going to take I-5 across and I-25 up to Denver. So I start at 340, I went down to New Orleans, then from New Orleans to Albuquerque, from Albuquerque to Denver. What is the altitude at Denver, Mr. Foster?
5,280.
So does it matter which path I take to get there?
No.
Will it affect the altitude? No, so I can drive to Pikes Peak, 14,000 feet high, then drive down to Denver, it'll still be the same.
Once you get a higher altitude on the way up, for a long amount of time if you go
The altitude of Denver won't change.
so it just matters the end point.
It just matters, yes, the end point is what matters. So altitude is path independent. But this is not a driver's ed course. Distance and altitude, that we don't care about that. This is a chemistry course. So what values are we concerned about? Well, Q, which is heat, W, which is work. So those two are non-state functions.